say? You're the CDC. You have to make a call based on this flu vaccine. Is it working? Is it working? Silence is consent. Therefore, the pharmaceutical can go out and start mass producing this and selling it to people for whatever they want because it works, correct? Laura said, no, it doesn't work. Hang on a second. Laura, you're shaking your head no. You tell me why.
Because 10% of the people got it.
Hang on. My muter, here we go. So we have one vote for, would you mind, Will or Laura, just throw that on real quick? And I'm going to move the table. Stop being Sisyphus up here. Oh, can you turn them on real quick? Sorry. It's very cozy now. Perfect. So is the flu vaccine working? Okay. One vote. No. And Laura, tell me again why.
Because more than 10% of the sample got it.
Good. So no, because more than 10% of the sample, looks like 10.1% is, because it's 101 out of 1,000, got sick. Good. Will, you're going to say something.
Yeah, it's working.
Yeah, it's working. Okay. Got some infighting at the CDC. Yes, it's working. Why?
Because the 95% confidence interval for the sample yields a range of values that are below 12%.
Okay, now hang on a second. This might go in direct opposition to Laura. Let's take a look. So Will has said, let's calculate a 95% confidence interval for the sample data. Let's do that, friends. I think it's a fantastic idea. We've got a tool already, don't we? We've got a tool. Let's use it. And the tool is a confidence interval around the sample data. So let's plug this in so we can actually see it. You know?
But doesn't 12% gotta have a confidence interval too?
Hold that thought, please, Eric. Thank you. Thank you. Yes. Hold that thought, my friend. I want you to hold that thought. It's a wickedly important idea, actually. Hold that thought. Hold that thought. So we're going to go over here. Which one is it, T or one prop Z in? Caleb, go ahead. One prop Z in, because what are we testing? What are we forming an interval around? We're forming an interval around a proportion. A percentage of those that get sick. That's a proportion. That's a little p. So one prop Z in's down here. Okay, fire. Can you see that okay? I'm sure you can see this. Ish. What's blocking it? Oh, the calculator right now. That's okay, I guess. All right. So we're going to go with X's number of successes, which I would assume be those that got sick. Out of 1,000, yes? That's 10.1%. I'm with you, Laura. 10.1% of the sample. But we know that that bad boy has to have a margin of error. That bad boy has to have a margin of error. And the margin of error is now formed by our 95% confidence interval. And this 95% confidence interval, Jesse Earls is going to say, damn it, Earl, that rounds to 12%. Will Downing says it's statistically significant. They're both correct, but by exact values, the rate of flu infection using the vaccine is going to be 8.2%. Whoa, that thing's not loving. 8.2% to just almost 12%, but just shy. So looking at that, it looks like the flu vaccine is working, a minimal amount at least, perhaps more. Now, I love what Laura's saying, though. I'm not saying a flu vaccine. Maybe we should do, to clear up confusion, because you're not convinced yet. Let's talk about what it means for a flu vaccine to work. What does it mean for a flu vaccine to work?
That it gets most people healthy.
And define most. Use the word more instead of most.
More.
Or fewer. Fewer people are going to get sick with the vaccine than without it. A flu vaccine can't possibly ascertain that every single person that uses the vaccine will not get the flu. But what it's supposed to do is lower the rate of flu statistically significantly. Go ahead, Rosie.
Is this a situation where the fact that it's over 5% doesn't really matter because it's still...
Here's the question. Where's the 5%? Where's the p-value? Where's the p-value? Trick question. Trick question. There is none yet. We haven't made a p-value. That's the problem. We haven't made a p-value. Confidence intervals don't have p-values. With confidence intervals, you're either in or out. If you're in, you're 95% confident there's no difference. If you're out, you're 5% sure there is a difference. So technically speaking, we're out. Now, this ignores something that Eric brought up. Eric's point is, shouldn't the 12% also have a margin of error? Sure, but here's the deal. When you've collected as many data points as they have on historical flu rates, what happens to that margin of error? It basically shrinks down to nothing. Essentially, the 12% stands on its own as a parameter. Essentially. But I love your point, Eric, because it ties into what Laura said. Even if the 12% has a little tiny margin of error, it's going to smack that confidence interval a little bit, isn't it? Yes! So, there's two things we can do to analyze this better. Number one would be rerun the study, drive the sample size up, and see what happens. See what happens. All things being equal, and we come back with a 10.1% infection rate again, what's going to happen to this margin of error up here? It's going to shrink. That was, I think, the question number one in your exam. If the sample size is increased, generally the margin of error decreases. And then the extra credit question was, why did I say generally? And this is tricky, but it's not hard to believe. Why might not the margin of error decrease when the sample size increase? What are you assuming? What are you assuming about your new sample data compared to your old sample data?
It's still at 95%.
Well, it's still 95%, but that we're still going to get 10.1% people infected no matter how many we ask. There's going to be variability across that sample, right? It might come back at 10.8, might come back at 9.5, might come back at 22.6. I mean, maybe we got really lucky with this one. Maybe the flu vaccine actually makes people sicker than better. We don't want that. But we could have gotten an outlier. Yeah, we'll come back to that too when we get done. Fair enough so far? You guys mind this? You guys mind this? Okay, good, good. So we need a new way, and a new way is actually not necessarily looking at just two-sided intervals, Will. I love what you did, by the way. But looking at a one-sided confidence interval. Now, if you look in your TIs, that tests menu, there's nothing called a one-sided 95% confidence interval for anything. They don't exist. The reason they don't exist is because they're called hypothesis tests. That's what the world tends to call these one-sided confidence intervals. But it's 9 o'clock. It's warm in this room. It's time to crack a window, get some cold air in here, wake you guys up a little bit. Go wander around. We'll come back and do steps 1 through 4. Yes! Get out of here. Walk around.